everyone, welcome back to Stanford Medicine, Tools for Healthcare Data Science. This is part 8 of tutorial 2. I'm Priya Desai. As promised in the last video, in this video we're actually going to try and build cohorts. Most of the queries that we have as examples here are queries that have actually come up in our office hours. So they're real queries brought to us by users like you. The queries, this is just a quick overview of the queries we're gonna try to get the answers for. The first one is how many patients in the Stanford OMOP DID Lite 1% data set actually took the ingredient warfarin. So this number is not going to be very large. Remember, it's only the 1% data set. Second, we're going to look for patients who took drugs associated with the ingredient warfarin, right? So this might be more because it's not just, it's all the drugs associated with the ingredient warfarin. Next, we'll look for patients who took drugs from all the drugs from the antithrombotic class. Then we'll start getting more specific, and this is much more like cohort building, which is saying we're going to say we want new users of warfarin who are older than 65. So we'll define what we mean by new users. The next one is new users of warfarin who are 65 and older and have had prior atrial fibrillation. And that would be a typical query that you would need for a study or a cohort that you would want to extract. And then these are just other ways, like if I know which person and I know which visit, can I find all the procedures and diagnosis associated with that particular visit? How do I find patients with conditions associated with a particular drug ingredient? So these are all questions that actually came up in office hours, and we just threw them in here. We thought they'd be nice examples to actually work through. So with that said, let's go to our notebooks. Okay, and I'm going to start right where we ended the earlier video. So the earlier video just ended right here. For the rest of this video, you are going to use something that you did way earlier in the notebook. You may not even remember that you did it, but let me just show you. So if you go way to the top, just when you were doing all your setup, yeah, I see what it. Okay, here. So this looks like I have an error message, but I'll tell you why I have an error message. It's because I tried to create a data set to store all the intermediate results. And for these, when you create cohorts, typically, it's often hard to create a cohort or write a complex SQL query at one go. So we really recommend that you break it up. And what you can do is you break up the SQL query, you create a temporary table. Then you create a temporary table from the next, for the next section, and then a temporary table for the next section. And then you can either combine them or find the intersection or whatever you need. So I think when I was rerunning this notebook right now, you have to create a data set where you will store all these temporary tables. I'm calling mine Tutorial2_Priya. You guys should make sure that you have called it something else, because if you call it Tutorial2_Priya, you probably also got this error message. And the reason I got this error message is because basically it's saying this already exists. So I can go back and look at my BigQuery console, and you can see this is SOM RIT start training, and Tutorial2_Priya already exists, right? So I can delete this data set. Let's go ahead and delete it. So I'll just show you that I'm So I'm deleting it. Okay, so now it does not exist anymore. And so now if I actually run this particular cell again, I'm not going to get this error, or I should not get this error. So let's go ahead and actually run it. Okay, so see, now it says dataset Tutorial2Priya, and it's been created, and I can go back and I can check. So I need to refresh. There you see Tutorial2_Priya has been recreated. All right, let's go back and get started on these queries. Okay, so the first one is just finding patients who took warfarin, just looking for the number of patients who took warfarin. So now, remember, we're no longer looking at the concept table, the concept relationship table, the concept ancestor table. Now we're actually querying the clinical tables, right? So that's where the actual data is. So for warfarin, the table I would look at is the drug exposure table. So I'm saying select, count distinct person IDs from the drug exposure table who have actually taken this drug concept ID. And remember, this drug concept ID we found out way up here when we found the standard concept ID for warfarin. So let's go ahead and run that. Okay. Let's go ahead and find all the patients who took the drugs associated with the ingredient. Okay, so now I'm not just looking for this one drug with this one concept ID. I actually want patients who took the drugs associated with this ingredient. So what I'm going to do is, so for example, you could have 100 people who took this warfarin, this particular concept ID, but you could have a whole lot of other people who took not warfarin, because remember, warfarin is a separate concept. Warfarin 500 milligrams, 5 milligrams is a different concept. 5 milligrams, 10 milligrams is a different concept. So if I want people who took not just this specific drug, but that and all its descendants and everything that sort of comes under its umbrella, I would actually say select count distinct person IDs from the drug exposure table, where this drug concept ID, I'm no longer restricting it to just this. I'm going to say the drug concept ID should be in the list of all the drugs where I make this concept ID the ancestor. So I'm saying if that's the ancestor, give me people who took this and all its children, right? So that's what I'm doing here. And this number, I expect this number to be equal to or larger than this. And it is just about, but it is. Okay. So now I want to go to an even bigger class. So I'm not just saying warfarin and all its children. Now I'm saying give me patients who took any drugs from the antithrombotic class. And you may remember we had actually pulled out the concept ID for the antithrombotic agents class. So that's what this query is doing. Excuse me. Go ahead and make, spend time, make sure you understand this query. Of course, if you have any questions about this query, please feel free to come to our office hours. We're happy to walk you through these queries. It's really important that you understand how you build this query. Okay, so go ahead, and I expect this number to be larger than that. So let's see what happens. Okay, good. So it's 1650. So remember, this is just a 28,000 patient data set, right? Because this is just 1% of the Stanford OMA DIB light data set. Okay, so now what we want to do, if you remember, is we're finding all the new users of warfarin who are older than 65. So the way we're going to do this is we're actually going to break it up. And what we're going to do is first we're going to say, so what do you want? What do you mean by new users? New users basically mean users that, so you have to figure out how you define a new user. Is a new user somebody who has not taken that drug in the past 6 months, in the past 1 year, in the past 3 months? In order to even determine that, that means you need to have information about this patient. So suppose you say a new user is somebody who hasn't taken this drug in the past 1 year. Well, I need to have data about this patient for a whole year before that to ensure that that person indeed is a new user, right? So what I'm doing here is I'm saying, okay, I'm creating a temporary table, CTE drug index, and I'm saying, just let me select all those people all those people and the minimum index date, so the minimum drug exposure date. So what was the date when they first took the medication, and which medication? The medication that belongs to this list of descendants of this particular concept ID. Okay, so go ahead and do that. And now what we're doing is we're creating or replacing this table. The work dataset ID I had set as Tutorial2_Priya, so that's where this is going to get created. So it looks like this query has run. So let's go back here and look. So now in Tutorial2Priya, I should see a CTE drug index table, and I do see that. And here I see person IDs and index dates. That's the date, the minimum date, the first date when they took that medication, right? So that's a person ID and that's the index date. Okay, now I can actually go in and read from that table. So what I want to go in and do is I want to find out how many patients are in that table. So I'm actually going in and counting the number of patients in that table that I just created. So 217, so I have 217 new users, 217 users of warfarin where I found out what their index, what their start date is. Okay, how do I find that they are new users and they're older than 65? So here what I want to do is, and this is why I found out what the index date is, because I need to find out the index date and I need to find out how many days I have in the observation, in their observation period before the index date, right? So that's what I am doing here. So I'm going to pull out, I'm going to create another table called CTE drug new users, and I'm only going to pull those patients, those people from this CTE drug index that I just created, where the difference between the index date, that is the date of start of the medication, the first day that you took the medication, and the date of the observation period's start date, right? So how long do I have information about these patients? What is the first day I have information about them? Difference between the first day I have from when I have information about them to the first day that they started taking the medication, that is my days before index, right? And I'm going to limit that. So I could limit that that to 365, which means that a new user will be somebody who hasn't taken the medication for 365 days. If I say days before index is equal to 60, then it's typically who haven't taken the medication for the last 2 months, and so on. Okay, and so I'm pulling those out, and I'm also trying to make sure that these people are over the age of 65. So here, and here's where I do that. So I'm pulling out all those people, but I'm going to say where the date difference. So remember, I pulled out the date diff. I call that days before index. And now I'm saying that days before index needs to be greater than 180. So basically it means I'm defining a new user as somebody it's the first time they're taking the medication in the last 6 months. Okay, so who have not taken this medication in the last 6 months. And I want them to be greater than 65. So how do I do that? Well, I look at the date. So I extract the year from the index date. That's the date they first took the medication. And then I look at the year of birth. And I say that the difference between those 2 years should be greater than 65, right? Because year of birth and index date is the date they took the medication. So if that is more than 65, I know they are 65 and older. So here, the new users of warfarin, meaning people who have not taken warfarin for the past 6 months and are older than 65, that's what I'm pulling out. But I'm pulling out from this subset that I created here, right? So go ahead and run that query. And, spend some time really understanding how these sort of subqueries are created and nested inside. And if you have any problems, any issues, we're happy to help you in the office hours. So, okay, so looks like that ran. That should have created a new table called CTE drug new users. Let's confirm that it did. So I need to reload. Okay, so see, here is my CTE drug new users. And here you can see now I have a person ID, I have an index date, that's the date I took the medication, I have the observation start date and end date, and then I have the days that I have their data for, how many days before index. So that's what I have. So like you can see, oh, for this person I have more than a year of data, this person I have definitely more than a year of data, this person less than a year of data. But remember, we're only going to look for people who have more than, who we have data for, for at least 180 days. So it looks like most of these people are going to be in our final cohort. All right, so we've created that data set. Now let's go ahead and just count how many people are in that data set. So I'm going to do that. And looks like there are 78 such people. Okay, so what if I made it more complicated and I said, okay, I want new users of warfarin, people who are 65 and older, and they have had to have a prior diagnosis of atrial fibrillation. So again, I'm going to use this basic, these sort of initial tables that I created, temporary tables that I created, and build off of them. So here now I'm saying we need to find people who have had atrial fibrillation, right? So I'm going to call this final table my final cohort, and I'm going to say just select those people where, now I'm actually going to start looking in the condition table, right? So I'm going to look in the condition table and I'm going to say, tell me the date difference between when the start date was and the condition start date for atrial fibrillation. So what I'm trying to see is they have had to have atrial fibrillation prior to warfarin, right? So the diagnosis of atrial fibrillation needs to have happened before the index date. And remember, index date is the date you first took your warfarin. So that's what I'm doing here. Okay, and the rest of it is basically, just, so that's my days of AFib closest prior to index date. And if I go ahead and run that, and now if I find the number of people for whom I actually have AFib, okay, so that's going to be smaller than this number, not surprising, and that number is 37. Okay, so here, see, this is where I'm doing that. The condition start date is less than the index date. And, CO, NU, I think you guys all know that if you have questions about the SQL and how to actually generate this kind of SQL, we actually have a tutorial, a short tutorial just pointing you to the really, some of the basic queries on how to create basic queries using SQL. That's a tutorial1_SQL notebook. It's also in GitLab, so feel free to download that and work through that. And that should help you understand this. Okay, this is a different question. It's like, how do I get drugs with 2 ingredients? So I had put this as a question earlier on. This is A10BD14. These are 2 drugs, metformin and repaglinide, and there's no standard concept for them. So how would we find patients who took these 2 ingredients? So here we're actually going to run 2 multiples queries, and we are going to create 2 separate data sets, and then we're going to look at the intersection. So here's query 1. This is query 1. So the cool thing about SQL, about BigQuery, is that you can actually run multiple queries at one go, so long as you separate the queries by a semicolon. So that's what we're doing here. Here, query 1, actually, this is commented out. So this basically this is just a symbol for commenting. So this query 1 and query 2 has been commented out, but I'm actually going to run this query and this query and this query, all the 3 queries simultaneously, one after the other. And each of them is actually going to create a separate table, a repaglinide table, a metformin table, and then a combined table which contains the intersection. So let's actually just confirm here what tables we have in here. So under tutorial 2, Priya, I just have these 3 tables. All right, so let's go ahead and run this query. And here too, we're doing it, the way we did it before, which is we're saying, hey, we're going to call it metformin ing. That's what the table name is. And I want all the descendants of the metformin concept ID. I want, I want all the descendants of repaglinide concept ID. So here actually what we're doing initially is we're just pulling out what are all the concept names that we should be looking at, which will be in this intersection of metformin and repaglinide. Okay. And then what I'm going to say is, so remember, here the question is, I'm not looking for how many people are taking this. I'm saying, can I get the list of drugs which actually contains these 2 ingredients? And that's what I'm pulling out. So if I look in here and I go back here now and I reload. Here I can see metformin, ing, repaglinide, ing, and then this is my intersection. So these are my drugs that that contain both, right? So this is their concept names. You can see this list of 17 drugs that contain both. Okay, next question. What if I wanted to know all the procedures and diagnosis codes associated with a specific person and a specific visit? So just to make sure we all get the same answer, we picked a certain person ID. It's pretty much at random person. We just make sure he's there in this data. The person is in this data set. Person ID 137312 and visit occurrence ID is that. So here too we will create a bunch of temporary tables. We're going to create a temporary condition table, a temporary procedure table, and both of those will be the tables that you would need, right? So here too, what are we doing? We are basically saying create this temporary temp cons, which is the temporary condition table, by querying the condition occurrence table, where the person ID is that and the visit occurrence ID is that, right? So it's going to pull out all the conditions. Similarly, the next one is going to just pull out all the procedures. So go ahead and run that. Okay, so now let's really go and find the conditions, right? So all we're going to do is actually read this temp cons and temp procs table. So we're just doing a select star, so let's do that. Okay, and so that person, these are the conditions associated with that particular visit ID for that particular person, right? So the person ID you see is the same. The visit occurrence ID is the same. And these are all the conditions associated with that person for that particular visit. And yes, sanity check, condition start date and end date is the same. So yes, we are indeed looking at that same one visit. Similarly, let's check all the procedures. And same person ID And here you can see these are all the concept names of all the procedures that happened that day for that patient. Yet another question that was brought to us by our users, find all the patients associated with the drug ingredient atorvastatin. So it's an ingredient of Lipitor, and that's the concept ID of that. So we want, so it's not just find all the patients who took that drug, it's find all the patients' conditions. So here I am saying, for each patient who took this drug, give me their conditions, right? And then I'm going to give you this huge list of conditions, different kind of conditions that people who took this drug have. And that's what this does. The only restriction that we're actually putting in here is that the condition start date is less than, so the condition happened before the drug, so condition start date is less than the drug exposure start date, and the difference between the drug exposure start date and the condition start date is within 3 months, right? So that's why we think that they would be associated with this same drug, right? Because we want the conditions associated with this drug, and you can define what you mean by associated. So here we're saying if they took atorvastatin within 3 months of this diagnosis, then it's likely that this condition is associated with this drug. So go ahead, and run that. And here you can see people who had this drug. Interesting, they had some interesting conditions. Bunch of them had retinopathy, sprain of interphalangeal joint of finger. But so this is just interesting, but this is how you would basically create that query. So I hope this has been helpful. We really look forward to seeing you guys in our office hours. Our goal is to really enable you to do your research, to make this, the goal of these tutorials is also to help you ramp up to understand and query using OMOP. We think OMOP is really powerful, and, we are here to help you. So look forward to seeing you guys in tutorial 3. Meanwhile, if you have any questions, feel free to come to our office hours. All right, thank you. Oh, sorry, before I say thank you, I think I have a last slide. Tutorial 3 is going to focus on Atlas. Tutorial 4 is where we will actually look at the OMOP DID dataset, not just DID Lite. So this would contain the notes and unstructured clinical text. For that, you will need Nero on-prem and Nero GCP. I will send out instructions on how you would get that. At that point, you will also get access to the Star OMOP user guide. And since this is the first time we're doing this, trying to use this flipped classroom model, we would love your feedback. So please take a moment and fill out this feedback form. And we look forward to seeing you guys. Thank you.
The preceding program is copyrighted by the Board of Trustees of the Leland Stanford Junior University. Please visit us at med.stanford.edu.